What if one person, working pretty much completely alone for 40 years, stumbled upon a kind of secret key to the entire universe? Well, today, we're diving into a really radical and, controversial idea that claims to do just that, to finally unite all the laws of physics into one single theory of everything. At the heart of this whole thing is a seriously profound question. A theory called geometric unity asks, did the universe have to be this way? Could its fundamental code be written in only one single inevitable way? And to really get why that question is so important, we first have to look at this deep crack that runs right down the middle of modern physics. So, to understand why anybody would even attempt such a huge project, you have to see the central problem. For more than half a century, our whole view of the universe has been fundamentally split, right in two. Okay, so on one side, you have Einstein's general relativity. This is our theory of gravity, of the cosmos, and it's just beautiful, geometric, elegant, like a perfect, pristine disk. But then on the other side, you've got the standard model of particle physics. Now this thing describes all the other forces and particles with unbelievable precision, but it's a mess. It's like this crazy, complicated jigsaw puzzle. And the biggest problem? These two incredible achievements are written in totally incompatible languages. They just don't talk to each other. And when we say messy, we really mean it. The standard model feels less like a fundamental law and more like some complex recipe with a bunch of ingredients we just can't explain. I mean, physicists literally have to plug in all these settings by hand. This very specific mathematical structure for the forces, these three mysterious copies of matter, the Higgs field, and then a whole shopping list of random-seeming numbers. It all works, don't get me wrong, but it feels so arbitrary. You just have to ask, where did this recipe even come from?
Right, so this huge divide has stumped the best physicists in the world for decades. Even mainstream ideas like string theory haven't really delivered the final answer. So, what if the solution wasn't going to come from inside the system at all? What if it had to come from a total outsider? And that thinker is Eric Weinstein. He's a mathematician who has poured the better part of his life into developing his theory, which he calls geometric unity. He even knowingly calls himself a unified field theorist. And you gotta understand, that term became almost a joke after Einstein's own very famous and very failed quest for unification.
So what is the central idea of geometric unity? Okay, get ready, because this is a wild one. It basically suggests that to solve physics, we have to completely change our minds about where physics is even happening. Weinstein proposes that the four-dimensional space-time that we all experience, it isn't the real stage. He argues that it's actually just a shadow of a much larger, much more fundamental 14-dimensional reality that he calls the Observerse. You can think of it as like the control room for our universe. Here's a great way to picture it. Imagine our 4D universe is the playing field in a giant stadium, okay? Now, geometric unity says the real action, the particles, the forces, the actual fundamental laws, it's not happening down on the field. It's all happening up in the stands, in that 14-dimensional Observerse. All we ever get to see is a projection, like a shadow of that higher dimensional dance playing out below. Okay, so we move all of physics from the field up into the stands. Why would we go through all that trouble? Well, if this totally radical shift in perspective turns out to be right, the payoff is just enormous. It claims to solve some of the absolute deepest mysteries in all of science. For example, why are there three versions of matter? It's one of the biggest why questions in physics. I mean, we have the electron and then two heavier, unstable copies. Why? Why three? How does geometric unity explain this magic number? Well, the theories claimed is just astonishing. It says the number 3 isn't arbitrary at all. It just falls right out of the pure geometry of that 14-dimensional Observerse. And it's not just that. The theory claims that all those messy ingredients from the standard model, the forces, the symmetries, even the Higgs field, they aren't messy ingredients you have to add in. They are necessary, unavoidable consequences of this higher dimensional geometry. So, if a theory is making these incredible claims, why isn't it being, celebrated in every physics department on the planet? Well, The answer is complicated, and it has as much to do with the culture of science as it does with the actual physics.
Trying to get a new, super complex and unconventional idea into the mainstream, it's like trying to build a ship in a bottle. You can't just shove the finished ship through that tiny opening. You have to find some clever way to build it piece by piece, working completely inside the constraints of that glass bottle.
Weinstein is a major critic of that very bottle. He argues that the modern academic system, with all its intense career pressures and its peer review process, is basically incapable of fairly evaluating a truly radical idea from an outsider. So because he believes the system is broken, he has refused to publish in traditional journals and has decided to just release his work directly to the public instead.
And this gets us to the ultimate point of a project like this. Whether this specific theory ends up being right or wrong, it's really about the nature of discovery itself.
It all goes back to this famous question from Einstein. See, a theory of everything isn't just about describing how the universe works. The real, ultimate goal is to understand why it has to be this way. To see if its laws are just a matter of pure mathematical necessity and not some cosmic accident.
A true theory of everything, then, wouldn't just be some equation in a textbook. It would be a revelation. It would be like humanity finally learning its own source code. And so we're left with this profound, almost scary question. What happens to us when we finally read it? What do we become when we understand the fundamental logic of our own existence? That's a question that goes far beyond physics. Thanks for digging into this with us.